This is part 3 of my 1951 Hickok 640 Oscillograph restoration project. The scope looked like an unnatural disaster when I got it, but in truth it probably wasn't that good. In part 1, I cataloged the parts and derived an as-built drawing from a revised schematic I had found online. I discovered that the scope had been dropped and found 6 bad tubes, including both rectifiers. Besides replacing the tubes, I started on a complete recap, including all electrolytics and wax capacitors. Part 1 ended after discovering that the transformer was bad, and finding a replacement would be highly unlikely or expensive. Part 2 documents the transformer rebuild. After I had finished that, I decided to unmount the choke in order to clean some paraffin that had leaked from beneath it over the years, and just to make things a little easier to remount the transformer. We pick up after I reinstalled that choke. I've reinstalled the choke back into its position after cleaning up underneath it a little bit to make sure that there was nothing else down there. Like I say, I didn't really need to unmount it because I'm taking an ohm reading on it right now and I'm getting 234 ohms, so it's definitely not shorted. At the same time, I've mounted the transformer back into its place, and I've color-coded the wires so that I know which is on which end of the transformer. Okay, the rebuilt transformer is wired in now, and I think at first what I'm going to do is just turn it on and see what happens. I don't think I'm going to take voltage measurements just yet. Getting some lights here. Okay, so I've got, it looks like every one of those tubes have got some amount of glow to them. Looks a little weak to me, but what do I know about that? Rectifiers look like they're glowing. Yeah, I forgot to check. Yeah, okay, so the CRT is glowing. I don't have anything on the CRT yet. Yeah, it doesn't mean that the CRT is good. I mean, it took a tumble. Oh boy, I hope that thing's not dead. Well, I mean, I'll start out. It looks like it's holding power at least, and it is lighting up some of the tubes, actually all of them. And I'm still running with the old capacitors here. But really, I do need to start from the very beginning and start taking voltage measurements. Taking a reading here on one of the high voltage leads to ground, which is where the center taps are tied off to. I'm reading 418 volts, and that's on the positive, what I call the positive side of that transformer. The other side is also 417. So it's pretty close to what we're looking for. I'm going to very quickly shut this thing off and move it to the next reading. Okay, I'm going to take a reading on the second half of the high voltage transformer. That's the, but on this one I don't dare measure to ground because to ground it's like 1300 volts. So in this case I'm just going to read across and look at the potential of that coil, and 1.2 volts is right about where we want to be. So that one looks pretty good. This one is, this should read about 6 volts or so. It's reading 6.8. That's a little bit, or 6.6. That's a little bit on the high side. This is the green leads. They go to the CRT. This is a 5 volt coil. and it's reading 5.1 volts. This is the original one that led me to start looking at the transformer. I'm reading 3.2 from the center tap, which is good. And on this side, this one's 3.2 also. So yeah, that's about right. If I read across it, I'll probably read about 6.3, 6.4. I could try doing that. I'm going to read across it this time. 6.4, 6.5 in that range. This one I can read from the center tap as well. This one should read about 25 volts. 26.9 on the one side. 26.9 on the other side. Sorry, I didn't have the camera there for the other one, but there it is. So, yeah, they're pretty close. They're not right on the money. But I think it's probably good enough output from the transformer. Now what I need to do is start going through and taking voltage readings at each one of these tubes that are marked on the drawing and see what I've got. Well, I wanted to start at square one, but I think I'm still behind square one because when I did that those power readings, I left it on for a minute or two just to make sure it would hold. And then when I touched this side of the chassis, it was hot. And I went around and touched this metal tube right here, the one on this side, and it was hot. The one on the left was not, and the CRT was not. Then I went on this side over here and I touched these new capacitors that I put in. They were fairly hot, but I think that was just radiated heat because it was coming from this capacitor right there. That thing was really scalding. The one on the left, identical circuit, not so hot, but I had, this was super hot and that was hot. I'm going to take some voltage readings in a few places along this particular circuit. They're both fed the same place. I'm going to turn the power on only for a little bit. I'm reading 460 volts, 400 coming in to both of those resistors. So I'm going to turn it off real quick and move the lead to the output. $458, $459 on that pin. That's the tube that does not get hot. So coming out of this resistor, there's a voltage drop, 164 volts. So it doesn't read exactly the same. Okay, we've got it hooked up to the output of the coil right now, or it's the output of the choke. I just want to see make sure that the output of the choke reads the same thing as what we were reading at the input of those two resistors. And it looks about right in the 460 range. I think that's about what we were reading over there. Let me move it to the input of that choke. So coming into the choke is 488, 489. So I would say, somewhere around 490 volts. One bit of good news I found is that if I observe the CRT during power up, I could see the trace appear briefly before it jetted out of range, but attempts at repositioning it were fruitless at this point. At least now I knew that I had a control failure rather than a bad CRT, though. Going back to the choke, the reading is 80 volts above what it is shown in the schematic, or about 20% above spec. The drawing doesn't indicate what we should expect to see going in, but we know that we're seeing a drop of about 30 volts from one side of the filter to the other. Here I'm showing readings I had taken of all resistors that were 1 watt and above. As it turned out, they were as bad as they looked, and almost all had drifted out of spec, particularly those on the B plus rail. The resistors outlined in red here show those 1 watt and above that tested out of spec as mentioned before. A few exceptions to point out include 2 small clusters that were associated with the high voltage coil. But within the B plus rail, there were 3 that tested fine because I had already replaced them for one reason or another. 2 installed resistors that I tested bad were just a different spec from what was shown in the schematic, and all 4 5 watts or above resistors tested out just fine. Most of the smaller resistors situated behind the higher watt resistors were apparently protected as they tested out fine. Those that failed were changed out along with the rest of the out-of-spec components. After replacing resistors, um, I'm noticing that the voltage really hasn't come down all as much as I would have hoped. Right now it's showing 465. It didn't really make much of a difference. Um, when this thing comes on initially, I can get it to stay on the display. If I adjust this thing a little bit, it'll show that it's multiple frequencies. Turn this up a little bit. See? But I'm not able to switch out of this mode and really do anything meaningful. Yeah, that's a recognizable pattern. It's kind of hard to see, but it's telling me that functionally some of it works. But if I switch to one of the other modes, I lose the horizontal trace altogether. See, there's no horizontal trace happening there at all. Those 2 big capacitors I never changed out. I think I'm going to go ahead and change those, see if that helps any. I've installed new capacitors in place of these old cans that you see sitting there. Uh, they're called condensers back in those days. What's it say there? Looks like it was made in Chicago. These are also Illinois capacitors, but I think they've been bought out. But okay, I put the shroud back on the oscilloscope over the top of the CRT because I finally realized that the reason I was getting different indications here on the screen, like it might cut off from here to here, and if I put it on its side, then maybe it cut off from here to here. And then when I put the shroud on it, then everything started working fine. Unfortunately, I still have a very high voltage condition here, but it looks like some of my the positioning commands are working a little bit better now. Uh, uh, Horizontal gain is working. Vertical gain is working. but there's still issues here that I have to iron out because yeah, this voltage level is still way too high. It should be, where I'm reading it at right now, should be 380 volts. So um, this is what it looks like if I try to use if I try to run one that should have a trace. It actually darts way off the screen, and you can see there's no trace, but there is a vertical deflection. I can increase or decrease the power of that deflection by manipulating the source. So it's able to do the vertical deflection part. It's just there's no horizontal trace. This one, which way did that go? Okay. So if I bring this over, I can get a the same type of thing, a two-dimensional trace. If I wire it in over here, I think, yeah. So now what you're looking at is I've actually wired in the horizontal deflection in there as well. See if I can bring them in to where they're about the same. So anything, you know, I can do XY type stuff, but I can't do anything on the time domain. So I don't know if that's a sync circuit or whether it's the sweep circuit, the sweep oscillator, but I'm going to have to take a look and, whoops, going the wrong way with that. So I'll take a look and see what I can find out with the horizontal trace. I turned my attention to the time-based trace issues, starting with the capacitors in the sweep selector. I'd skipped over them initially when I did the recap since they weren't as easy to get to, but a few of them were the old wax type, appeared tacky, and clearly needed to be replaced. I removed a few leads and rotated the switch. Then I lifted one lead on each of the four I felt needed to be replaced. They all measured out of spec. I did leave the micas in place since I have rarely seen them go bad. Here I've lined up the replacements. Note that the new ones are bigger only because they handle higher voltages. The one on the right is a bit of a kludge because I didn't have the right size. After replacing the caps in the sweep selector, I decided to take voltage measurements on the 884 tube, starting with pin 3, which should run about 50 volts and trigger the caps in the sweep selector. Then I measured pin 5, which should be the signal from the sync circuit, and finally I measured pin 8, which should be the feedback from the caps in the sweep selector. Pins 5 and 8 measured within the values called for in the schematic, but pin 3 was measuring about 40% off from what was shown. I decided to trace the sync circuit out using another oscilloscope through to the 884 tube since it was supposed to control the 884's discharge. I won't show the entire process, but I observed all of the sync sources from the sync selector through the sync circuit and all the way up to the 884 tube. It's kind of interesting to see the shape of the waves change along its path, but in the end I found out that all of the sync sources made it up to the 884. So that's good news. The sweep circuit goes all the way through, or I'm sorry, the sync circuit, all of the sync sources make their way all the way to the sweep oscillator. So the next thing is to check to see if we're getting anything out of there. This is where the trail ends for this. I would have thought that you would think at this point. I'm actually looking at the input to um, what is that? V5, just the other end of the wire. But I've checked the other end of this thing too, and we're not seeing anything coming out of that thyratron tube. So that, if you remember, that was the tube that I sort of held onto and said. It's important to remember that some of the functionality seems to work fine. We can generate two-dimensional Lie-Sajou patterns through the horizontal amplifier by feeding signals through both the horizontal and vertical inputs. So at the very least, the horizontal amplifier appears to be functioning fine. So the obvious question is, how does the horizontal amplifier get its signal? And where does that breakdown occur when handing a similar signal off from the sweep circuit? We can see here that when the selector is set to either the horizontal amp positions, the signal is routed through the other half of that switch to the control grid of V1. If we were to switch the selector to one of the time-based traces, though, we see that the input is no longer routed to the horizontal amplifier. Following that lead, we find that it terminates on the sweep selector, and this is how the Hickok implements its external capacitor capability by making use of the DC horizontal input when the selector is set for a time-based trace. As it happens, we can leverage this external cap capability to further isolate our trouble by setting the sweep selector to external cap. This should route our signal back through the same circuit employed by the sweep to effect a horizontal trace. Somehow, through the black magic of tube electronics, the signal finds its way back to the horizontal selector. And since the left half of that selector is already set to a time-based trace, so too will the other half. The signal is routed to the control grid of V1 and follows the same gauntlet all the way through the horizontal plates in the CRT. Given that this path checks out, it provides further evidence that the problem should be isolated to the sweep circuit. I demonstrate this functionality here using a Lie-Sajou pattern and show that it can even be leveraged to simulate a time domain signal, at least of sorts. We can make this look a little bit more like a time-based trace if I turn up the horizontal gain and increase the frequency that I'm sending. Let me increase this a little bit. Yeah, there we go. So we're simulating a horizontal trace by actually feeding it back through the external capacitor binding. What is the binding post for the external capacitor? And just making a trace that looks like a time-based one. Now, when you look at this, I've got them going in two directions right now, and the reason that that's happening is because this is actually a sine wave over here. Take this set of leads here, and that removes that trace and drives that right back up to 260 volts on that side. All right, so you can kind of see the trace that it's driving right now there. Now, I can change the type of trace because I have this is actually a function generator. And there's a triangle, and there's the ramp. So this is really what I want to work off of, is a ramp, because if you think of the sine wave, it has a bit of approach before it hits the peak, and then it has a bit of approach before it hits the bottom again. So that's why you're seeing it go back and forth. With this, it only goes one direction, and then it drops right off. So we should see something that looks like a time-based trace when I plug this back in, because right now it's got that ramp trace on it instead. So let me move it over here so we can see it. It's a little, see, you don't really see anything going back the other way. It's just moving in the one direction because we have a ramp signal on there instead of a sine wave. I think basically what it shows is that most of the circuit is working fine on the horizontal amplifier part, and whatever signal conditioning takes place at 2B5 as it kind of hands it off to the horizontal amplifier. So I think it's really pushing the issue back towards the 884 tube. I got my RCA 884 tubes. They were new old stock, and I replaced it in my CRT, and it did no good at all. So it kind of made me think I need to start looking elsewhere to see if I can figure out what I'm up against here. And I'm turning the Hickok back on here for a second. I'll turn on an external source so that we can get some waves going. It made me start thinking, where else can I look? What have I missed? I've tested this thing, the entire sync from the switch where you can change the sync sources all the way through to the 884 tube. And then on the other side, I've tested it from the sweep selector all the way through to the horizontal amplifier and eventually the CRT. What am I missing on here? And it seemed like the only thing that it could have been was that 884 tube. But I've tried both of these, and I get exactly the same results, so I put the original back in. What I started doing was, I was just kind of playing around with the idea of trying to figure out a way to align them horizontally on any one of these selections on the horizontal selector, because when I turned it to either one of the time-based ones, it was jumping way off the screen. And as I was messing around with that, I started noticing that if I flipped through the sweep selector and selected different capacitors, looking through here, you don't see any change. There's a slight one right there, a little bit of a bounce on the switch, but for some reason right there, I see something that almost looks kind of like a trace. That's the lowest setting. And then you get to the external capacitor, which is how I did my testing, just to make sure that everything works from the sweep selector all the way to the CRT. So when I'm looking at this, I'm thinking, what is going on there? Why do I see what looks like a bit of a trace when it isn't having to move at all? So, and I turned it over to the other one, and it's a little bit more, and I started thinking about what exactly is a driven sweep compared to a recurrent sweep. I mean, a recurrent sweep, obviously, that's something that's going to show pulses all the way across the display when you're in time-based mode. It just seemed kind of odd to me that when I switch between that lowest setting, I get something that looks kind of like a trace. And so what I wound up doing was looked over here at this potentiometer right here that you see. That is actually something that does a sweep adjustment for the for this driven trace. So I thought I would, so I turned the knob and I turned it all the way. I just flipped it, and all of a sudden I got this. This is a time-based sweep. So I turn this thing all the way over from here to the left, and suddenly it kicks in. And I move the horizontal over a little bit, and you're looking at what is essentially a time-based sweep. This is set internal right now, but I found that pretty interesting. That the thing that's missing on this, is it possible that it's just that I've had this sweep setting wrong? I've played with that sweep setting. Now, I've never turned it all the way over to the left like that, you know? In fact, now if you look at it, it's like I hit a threshold, a small threshold, and all of a sudden it turns on. And for the rest of it, it's off to the right there. So I probably never got that far to the left to be able to make that work. So I think there must be something wrong with that potentiometer. This thing was frozen rock solid, and ordinarily with something like that, you can see that there's a little bit of, I think you can see, so there's some red paint on it. Ordinarily that means that they set it to a fixed setting. They put the paint on it to dissuade you from ever changing that setting. But this was worse. It was actually rusted shut when I got it. So I had to, I wound up having to move it. So anyway, I decided to go in here and just to make sure, and I changed the frequency, and the frequency changes on the display, so it's handling that pretty well. I went to higher frequency, and here I jumped to a higher frequency on the sweep selector. So all of those, so the other capacitors are working. These two, oh, wait a minute. What are those? I think those are the TV settings. Those are just repeats of other settings. So this one probably is a repeat of this one, or maybe one of these other ones, but it uses the same capacitor. I wonder if I can get that to, yeah. So yeah, it looks like it looks like all of the capacitors are good on the sweep selector, and this is the internal sync. So if I take, actually, let's just have a real quick look at this. That's gone now. Oh, if I move this over, okay. Well, I've been monkeying with the frequency now, so frequency settings on my function generator, so you're not going to have that perfect trace anymore. It moved everything way off to the right, off to the left, but I want to figure out what I've got, so I'll realign all this stuff later if I have to, in order to center all of these different settings on the horizontal selector, which is what I was trying to do when I stumbled across. I'm going to try moving this down and using it as an external sync if I can. Yeah, see, that changes everything there. And I'm going to I can hear one of the tubes whistling. So I've got, I forget what that's called when that happens. There's a word for it. It does like a harmonic whistling sound. I don't know if I can sync this up, but what I'm trying to do is modulate a signal here. Try it up here. That's closer. That actually looks pretty good. I mean, let me move it down vertically a little bit, but you can see that it's kind of curved on each end of here, in ways that don't, it doesn't look too good, but again, it's probably something that I can work on. It was synced up a little bit there for a second. It looks like I'm getting good responses out of the locking. And the locking apparently helps lock in the sync, and then the vernier helps with the horizontal trace to sync up. So uh, it looks like I'm getting good results out of this stuff. It's not in that bad a shape. I still have the voltage issues that I'm going to have to hammer out, and that's going to probably take forever to figure out. But I've got the ICO sitting here, and I've tied this down on the output of the 884. I'm actually on V5 though, but what I wanted to see was that all along since I've been working on this, I do see the sync pulse going into the 884, but I never saw anything that looked like it was working with the sync selector at all. So I was expecting to see something that looked like kind of similar to the sync pulses. So I'm turning this on now, and you can see there is now on that pin we're seeing something. It kind of ramps up. Let me see if I can get a little more vertical in there. You can't really see the pulse going back down on here. See if I can get it to come in. It's jumping a little bit, kind of odd, but what you see happening is that it goes up and then it drops straight down. And that's what you would expect when it's discharging, when the tube discharges and it sends something over to the capacitors. And that's how it works. In other words, if you recall, we were getting 260 volts and it was driving the trace all the way off to the right, way over that way. Well, that's the same thing that's happening here, only it's staying within the display. It goes up, it moves it over, and then it drops back down, and during that time when that voltage goes down, it sends it back over to the left. So at least now we're seeing what we're expecting to see, what I was expecting to see on that 884 tube, on the plate side anyway. Okay, anyway, that's where it's at. I do have a time-based trace now, and I'm at a point now where I probably need to go through and figure out what the deal is with the voltage now. Okay, I'm getting a sense of what the voltage differences are now. I'm going to turn this on, and I'll turn on this meter here. It turns out that this before was reading about 400 and maybe 460 volts when it powered up all the way, and now you can see that it's down running at right around 412 volts, something like that, which is within 10% of spec. It's supposed to be 380, so it's closer to spec right now. What it wound up being, before I had to replace these, I had to replace both of the rectifier tubes. This is one that I bought. It's a Raytheon, and it's marked 5Y3 GT. This is the one that I replaced. It's older. It's also a Raytheon. It says it's Uniline, made in the USA. I really started thinking in terms of maybe it's the voltage is bad before it even gets to the choke. So I was actually starting to think about putting a high wattage resistor in prior to where it hits the pi filter, which is the choke. So just to bring it down a little bit more. But then I started thinking, well, there's got to be something else wrong, and I looked it up and found out that the newer new old stocks of this tube doesn't have the same voltage drop as the old stock of these tubes. This old type drops a little bit more. And the way that I found it was on a discussion group that's like 15 years old. And those guys were talking about it. They had the same issue where a guy was saying, not all 5Y3 full wave rectifiers are equal. And what they wound up saying is that one of the clues that you've got one of the newer ones that doesn't have the right voltage drop is that it only has 4 pins on the bottom, and that the structure, that this internal structure, when you look at those plates and stuff inside there, it doesn't look the same. Now, you can see, first of all, yeah, this one's got 5 pins on the bottom. This is the one that I replaced. It's got 5 pins on the bottom, and the structure's quite a bit different than that other one. So I did happen, for some reason, I bought 3 of these. Usually I'll try to buy 2 in case I make a mistake and screw something up and burn something up. At least I'll have a second one to fall back on. And I bought 2 of these, and they came, my coffee cup's in the way, but here's the box. It came in this plain brown box, Raytheon 5Y3 GTs. And they both look like this. They have the yellow markers on there. It doesn't say anywhere that it's made in the USA. Not that that's the most important thing about it, because it's not, but it just says registered on the bottom of that. It says Raytheon. I don't know if I can focus in. Raytheon registered. So it was made by somebody else for Raytheon, I guess. Anyway, at the same time, I bought a singleton from somebody else. So I bought these 2, and for some reason, I don't know why I did it, but I bought one by itself. It was a tube that looks like this. It doesn't say Uniline on it. It just says Raytheon made in the USA. And it has the same structure. It looks the same. It has 5 pins on the bottom, and that's what I've got plugged in there now. So that's what made the difference in the voltage drop. Now we're down to about 412, you can see. That's within 10%. So that's really getting to the point where I can feel a little more confident working on this thing, that I won't burn it up. Also, I was, since I did rebuild that entire transformer, I was pretty worried that I might have done something wrong or overlooked something in there. I tried to be as careful as I could when I was rebuilding it, but you never know, right? And this makes me feel like, okay, maybe the transformer's okay after all, and maybe I can look for solutions later on to try to mitigate the remaining voltage issues that I have. But And it's going lower and lower as time goes on. I wonder what it's going to finally, no, it went back up to 412. It's going back and forth a little bit. Anyway, I think I'm gonna put the part of the transformer and the voltage supply issue behind me and start chasing after all of the obvious bugs like this one that we're looking at right here. There's a lot of them that need to be fixed on this thing yet. So this thing doesn't want to lock in this morning, but that's not what I'm looking at right now. I'll look at synchronization and locking and all of that kind of stuff a little bit later. But one thing I notice is that when I push the gain up, that's this gain right down here. When I push it up, it expands from the left to the right. And that's not the way this is supposed to work. It's supposed to expand from the center out in both directions. When you move the gain, you're supposed to be zooming in on an area of interest, not chasing after an area of interest that's off the screen somewhere. So I don't really have a manual to work off of for this, but ordinarily this type of alignment is done by messing with the gain. You know, I've had two other oscilloscopes I repaired. One of them was just by replacing capacitors, and that's how it centered it. But this one, I think it's some combination of that DC balance and the horizontal gain. And what you do is you turn the gain all the way down, and then you use the position knob to recenter the trace. And I'll center it there. Yeah, you're supposed to move the gain back up before you do this. And then use the screwdriver on the balance to kind of line it back up again. And try the gain again. I don't know if we're getting closer to the center or not, but I'm still off to the right. Huh. Anyway, that's how I'm going to approach this. See if I can work this more and more. I'll do it off camera, but that's the process. I wasn't able to center it using this DC balance here, so I wound up putting it back to where it was, but I found that I could get it to center by, that's the 0 volt balance right there. So I think it's 0 volt DC balance. And when I do this now, you can see that it expands from the center. It turns out that the right spot is about center for these other settings that are not time-based. Here is, see none of these are time-based settings. They're the 2D type of traces. And now I've got them all so that they're centered in the same place. But anyway, if you look at this, you can see that on both ends, it kind of distorts or compresses or whatever you want, it crowds. And when it's on both sides like that, it's called a barrel distortion. And you know, if it was on just one side, if it was real wide on this side and very narrow on that side, you just call that a linear distortion. And that knob back there is for the linear. I've turned that, and it really doesn't make any difference for this, but I'm gonna have to take a look at the schematic a little bit. I think maybe there's a couple of resistors that I haven't changed out yet that might have some impact on it. I've replaced those two resistors that were back by the linearity potentiometer. Instead of having a barrel type of distortion. Now I've got that pen cushion thing where there's more stuff concentrated in the middle. If I show this, you can see it expands nicely from the middle, but it's also tighter in towards the middle than it is out on the ends. So I've got to keep looking. I went from 27 kilo ohm, 27K ohm resistors and put in what was shown on the drawing, which was 47. And it changed it from what I had to what you're seeing now. This is after adjusting it with the calibration pot on the bottom. So I've changed the two resistors in the over by the linearity pot, and then I adjusted the calibration pot, which is on the bottom. It's R48. It's not perfect still. You can still see the issue, but it's getting, it's closer. It's a lot better than it was. So I know what I have to do in order to improve it if I want to spend more time working on that. It's a lot of back and forth. It's like a little game of tug of war, kind of. But anyway, so now I have to try to figure out what the deal is with, I don't know if it's the locking or whether it's the sweeper near or what. I've got, I noticed that there's issues with the sink. It seems to be working pretty good right now. Let me turn on try a different type of pulse here. See, what's weird about it is that it doesn't really lock in real well. I guess that's not bad right now, but I've seen it where it looks a lot worse. So let me tinker with it and see if I can see other issues here. This morning I've got the scope turned on its side in order to fix some of the compensation problems that we have when you put up a square wave on this thing. This is a square wave. You're not seeing the vertical ones because I don't think the scope is fast enough to be able to draw those. And these look pretty good. This is the baseline ones. They're adjusted using this vertical attenuator here, and I've got the knob off. You can see that it's pointing into nowhere right now, but that's the one-time multiplier, which means that it's not going through any capacitors at all. So when I turn it 1, you can see I actually have to increase the power on my function generator, so you can see. But you can see you can see right there that it's overcompensated on there, where you can see those hooks on the end of each one of the lines. Now a little bit of overcompensation is okay, but not this much. I mean, what's happening is that it's going up towards its power level and it's overshooting it. So what I have to do is go in for that channel, which is the times 10 multiplier. I've got to go in and fix the compensation problem for that. Now if I move up to times 100, adjust my function generator, you can see I have the same issue there. and then there's times 1000, and you can see little hooks on there, but you know, I can't really do much adjustment to get that to to draw that. That's if you're really pushing something that's got high voltage across there. So anyway, yeah, I have to adjust those three channels: the times 10, the times 100, the times 1000, and get rid of this overcompensation. Where that's done at is that usually on almost all of these oscilloscopes of this, you know, this age, they have like a little, those are that's a trimmer capacitor. If you can see just beyond this rod, there's three of them there. And actually, I don't like the way that one's laying. It looks like it's almost touching the wall on the bottom one down there. But those three are used to adjust the compensation on that switch. That is the switch, by the way, and they've got a mounter right on there. On the ICO, they were mounted in a much better place. You know, this is very hard to get to. I guess they figured you wouldn't do it very much. Before I even do this, I think what I'm going to do is rotate that switch a little bit to get that one trimmer capacitor off the side wall there. And that'll make it so I can get to all three of them without too much trouble. And let me do that first. I'll rotate the switch and then show you how I adjust these. All right, I've rotated the switch so that it's lifted off of the wall there, and I should be able to get to all three of them now. Make the adjustments. I've got it set at the baseline setting, which doesn't have an adjustment that I'm aware of anywhere. But let me turn this to the first and increase the scale on my function generator. And what I'm going to do is I'm just going to guess which one it is and assume that it's the one on the top. And what I got to do is take my screwdriver and put it in there and just turn it a little bit. It's just a regular trimmer like you see anywhere else. So and that's about all there is to it. Let me go to the next setting. Whoops, I got to change the channel on here first. Whoops, this one's not staying in sync. Again, I'm gonna, now that was the top one, so our guess was good. I'm gonna assume that this one is the middle one. And we'll see what happens when I try to adjust it. A little bit of overshoot is I think what you would want. Not much. Okay, so that's the second one. Let's up this setting one to the times 1000. Now I don't have anything that goes that high, like I said before. I just have to crank it as high as I can get it. And we know that it must be this bottom one here, the bottom trimmer, the one that's a little hard to get to, but okay. Okay, so these are all they should be properly compensated. Let me shut this off for a second here. Made a couple of changes this morning. The first thing I did was I went back and recentered all of these pots, every single one of them, including that one there and the one on the bottom. And by centering, I mean if they've got 270 degrees of turn, I set it at, right down the middle at 135 degrees. So, and if you remember yesterday, what I did was I went ahead and fixed this part first, where it centers as it spreads, and then I came back and fixed the barrel roll. And yesterday I was starting to have problems towards the end of the day, and I couldn't really identify what it was. So I went back and recentered it this morning, and instead of fixing the barrel roll first, what I did was, I did fix the barrel roll first before I fixed the centering part of it, so that this morning it actually, at least to my eye, it looks like it's behaving a little bit better. Second thing that I did this morning was, yesterday I was hearing a lot of whining, or I don't know what the whistling coming out of a couple of the tubes. It almost sounded like it was coming out of the CRT, but I think it was actually out of the tubes underneath here, which is the horizontal amplifier and the horizontal sweep section. So what I did was, I was also having trouble bringing in the synchronization, getting the sync to work properly. So I went ahead, and there was a 12AU7 in the sync selector circuit, and there were two 12AU7s in the horizontal. One was in the horizontal amplifier, the other one was in the horizontal sweep, and I was actually just trying to get rid of the whistling. So I assumed that there must have been some compatibility issue with those two in the horizontal amplifier and the horizontal sweep. So I just took one of the 12AU7s from the horizontal sweep and just swapped it out with the one in the sync selector. And since I did that, everything seems to be working just fine. Both I don't hear the whistling. I'll wait to see if it comes back later today, but right now I don't hear any of that whistling, and I'm not having any difficulties at all getting it to lock in down here on the sync, external or internal, which I couldn't get it to work hardly at all towards the end of the day yesterday. So thought I'd report on that. The stuff on the cloth are the components that I replaced during this restoration. On the right hand side, you can see these are all of the capacitors that went bad. These two, I'm not sure. These might be good. Those two condensers from Chicago, Clark Street, in fact. It's actually got the address where they were made. Oh, that's upside down. I lived there for many years when I was young. So I had quite a few capacitors, but those most of those I would have replaced right at anyway, because well, you can see there there's a couple that were smashed, it looks like, or blew out, one or the other, and then all these other ones are just coated in wax. And these knobs wouldn't come off. In fact, I wound up having to break one of these knobs in order to get it off. This is the handle that broke. I got all the parts to it. The fuse holder must have broken when they dropped it. And right here is what's left of a potentiometer. I had to pry that apart just with a pair of 9-inch pliers in order to get it to remove from the cover, because it was rusted on there. Those, for the most part, on the left-hand side, actually all of the bigger ones you see of those resistors, those were the 1 watt and above resistors that all measured bad. The exception are these two down here on the bottom. Those two measured good, but those were the wrong spec, and they were causing that barrel effect that I was having on the display. So I replaced those with 47 K ohm resistors instead of those 27s that you see there, 27K. All of those tubes were bad. The 4 12AU7s were, they had lost their vacuum. The 1B3 that you see on the left, that one was cracked, and the 5Y sitting there, that one just went bad over time. So I usually don't replace this many parts but this thing had quite a few issues associated with it. Not shown here are an additional 7 capacitors that are in the can. They were in those cans. I just left those in place. They're retired in place, at least for now. Those cans, the way that they sit, are upside down, so that I don't think that they will leak out anything. They're probably fine where they are. Also, the transformer was a rebuild. Now, the transformer, I rebuilt it as best I could. I don't know what is the best way to rebuild a transformer. That's just the way I did it. But caveat to mention is that if you're going to do something like that, you should probably research it and make sure you understand, as best you can, what it is you want to try to do. So anyway, I thought I'd show it. Quite a few parts replaced on this one. Well, this is the first time it's had the cover on it since I've owned it. I mean, even when I received it, it didn't have the cover on it. It was just sort of jostled around a little bit. As far as cosmetics, I didn't paint anything. I just kind of cleaned it up, knocked most of the rust off the top. There's still bad spots up there, but and the same with the sides. The front, I ran into issues because I think it was originally painted white, and the paint just peeled right off. So fortunately, the text part stayed on there, but it should really be painted white. You can still see some of the white left right there around that knob where it wouldn't actually come off. But yeah, I think I'm just about done with this thing now. I'm gonna play around with it for a little bit and then find a good sturdy spot to put it. It'll probably wind up on the wood table because it weighs, with this cover on it, it's gotta weigh 60 pounds. Now, I went ahead and got all the replacement parts I needed, except I haven't gotten a new handle. I haven't decided what I'm gonna get. I think I'm gonna get one of those with maybe a couple of those with the big powerful handles that they use on guitar amplifiers, or the stuff that the roadies put their stuff in, with those heavy duty handles that'll flip open 90 degrees, something like that, made out of heavy duty steel, because the one that was on there really didn't work. Let me go find that thing. This is what's left of the original handle right here. This little thing, this piece of metal, it actually broke there. It used to have 2 sides on it like this. And I imagine that what happened was that handle was, it was covered in leather probably. Sat here, connected to another half back there. And it had a metal strap for reinforcement in it. And that broke. And when that broke, it probably took the whole thing down with it. So it's kind of I don't know what I would describe the color as. It's green or it's brown. It looks almost like a military type color to me. But this is the only 640 I've ever seen a picture of, so yeah, I'm going to take some pictures of it and maybe send it to the one of those sites that documents this equipment. Anyway, thanks for watching.